and welcome to Logos Learning. In this video, I'm going to show you how to derive the quotient rule from the product rule. So these rules are rules we use to derive products and quotients. So let's take a look at the product rule first and then a quotient rule so we know what we're working with. So the product rule is a rule we use to derive a product. So here we have a function h of x, which is a product of f of x times g of x. So to derive this h of x, we derive the first function, or the first composite function f of x, we multiply by g of x, plus f of x, the way it is, not derived, times g prime of x, so we derive g of x. So we have two terms here. In the first term, we derive the first function. In the second term, we derive the second function. Okay, so this is derived here, this is derived here. Or in Leibniz notation, so this is Leibniz calculus notation or derivative notation. Here we have the derivative of h of x with respect to x is the derivative of the first function f of x times g of x plus f of x times the derivative of g of x. Now the quotient rule is the rule we use to derive a quotient or a fraction. Functions one on top of the other, one in the numerator, one in the denominator. So to derive a quotient, same thing here, derive the first function, multiply by the second, so numerator, denominator, minus, leave the numerator the way it is, multiply by the derivative of the denominator, and divide that by the denominator function, underived, squared. And this is how it is in the Leibniz notation. It's a lot longer, a lot wordier or letterier. Now let's see how we can derive the quotient rule from the product rule. And I don't know why teachers ask that, but they do, and it's good to know how to do that. So here is our quotient, right? We want to derive the quotient rule from the product rule. So the first thing to do is to rewrite this quotient as a product. Now, don't forget this specific rule here. 1 over m to the power of 2. So we have a variable in the denominator. That is equal to, if we want to bring this over, if we want to bring the variable to the numerator, we just switch the sign of its exponent. So we're going to switch it here. M goes on top, we switch the sign, and then the 1 goes on the bottom. But again, everything is over 1, so we don't really have to write m to the minus 2 over 1. So this is m to the negative 2. So this g of x here is to the power of 1, as is f of x. They're both to the power of 1. But we're looking to bring the denominator to the numerator. We want to bring it up. If we want to bring it up, then we have to change the sign of its exponent. So let me rewrite this here to illustrate it. So g of x, h of x equal to f of x times g of x, but now that is to the power of negative 1 because it was to the power of 1, but we changed its location from denominator to a numerator. So now we have a product, correct? This times that. But this function is now a composite function. It is g of x, but it is all of that to the power of negative 1. Okay? Now, what is the product rule? Just to remember. So h prime of x, you derive the first function, you multiply by the second unchanged, plus you leave the first function the way it is, and you multiply by the derivative of the second function. Okay, let's apply that. H prime of x is equal to the derivative of f of x, so f prime of x, right? Times times g of x the way it is. So times the second function, which is all of that, right? This is the second function, g of x to the power of negative 1. Plus the first function the way it is, f of x, times the derivative of g of x, the derivative of the second function. Now the second function here is a composite function, and don't forget that when we have composite functions like that, we use a chain rule. Okay? So for instance, before I continue with this, let me just show you. If you had 2x squared minus x to the power of minus 1, what would you do? Well, you would derive the outside function first and then derive the inside function, correct? Using a chain rule. If you don't remember this method, please view my chain rule video. Minus 1 times 2x squared minus x. So you bring the minus 1 over and then you drop this a power, so it becomes the minus 2, times the derivative of the inside, which is 4x minus 1. Now we're going to apply the same principle, the same chain rule to this function to derive it. So this becomes minus 1 times g of x to the power of minus 2 times the derivative of the inside, which is g of x, so g prime of x. Okay, now we're just going to work with it to beautify the function. So here we have f prime of x times g of x. So I'm going to bring this to the denominator because I don't want my final answer to have negative exponents. Just like we brought it up here, just like we brought it up, we change the sign of the exponent, we're going to bring it down. So f prime of x over g of x to the power of 1, which we won't write, plus f of x, and let's see what's going on. What is this mess here? Okay, so here we have f of x times, let's work on the inside a little bit. So here we have negative g of x to the power of minus 2. And, oh, we're going to bring this to the denominator actually because it's the power of minus 2. So we're going to leave the negative on top. So negative 1 stays on top and multiply by g prime of x. And then this entire thing here is we're going to drop it to the denominator by changing the sign of the exponent. And again, we can do that because this is one term here. All of this is one term. So we can drop things to the denominator and numerator easily like that. Now, g of x, and that is the power of 2. It was minus 2 here, now it's positive 2. So that's what we have here. Let's continue. Nothing we can do to the first term, so f prime of x over g of x. And on the second term, we have positive times negative, so we're going to make a negative. Negative f of x times g prime of x over g of x squared. Now we can make this a little bit better. So here we have a denominator of g of x, and here a denominator of g of x squared. So if we want a common denominator, we can multiply both. We can multiply here this whole fraction by g of x. So if we multiply this by g of x, we have to multiply the top as well by g of x. Let's see what that becomes. F prime of x times g of x over g of x squared minus f of x times g prime of x over g of x squared. Now there is no need to have this whole thing under two denominators. We can put them under this common denominator which we have produced. So f prime of x times g of x minus f of x g prime of x over g of x squared. And lo and behold, it is the quotient rule. We have derived the quotient rule, which we have written here, from the product rule, which is written right here. So we just transformed, where is it? Which we rewrote this quotient as a product, and we derived it using a product rule. We beautified the function a little bit, and we have derived the quotient rule from the product rule. So let me write here h prime of x. Alright, so I hope this helped you guys, and I hope that if your teacher asks you to do this in class or on a test, which is very likely, then you'll be able to do it after watching this video. Alright, if you have any questions, type them up in the comment section. Bye!